Example number 3. Using a Venn diagram to solve a probability problem that involves two events. A school newspaper published the results of a recent survey. Eating habits. Students' survey results. 62% of students skip breakfast, 24% skip lunch, and 22% eat both breakfast and lunch. Well, good for them. First things first, first let's read the questions, and then let's make sure that we define our sets before moving on too quickly. So question A, are skipping breakfast and skipping lunch both mutually exclusive events? Determine the probability that a randomly selected student skips at least one of breakfast or lunch, and determine the probability that a randomly selected student skips breakfast but not lunch. So, the question is, are skipping breakfast and skipping lunch mutually exclusive events? I mean, like intuitively, we know that somebody can skip both, or somebody can skip only one, breakfast or lunch. But, I mean, it's conceivable that somebody could skip both breakfast and lunch. And so that means that, yeah, sure, they're not mutually exclusive. But let's mathematically investigate that. So our hunch is no, but let's see. 62 plus 24 plus 22. Now, if in fact they are mutually exclusive, it means that there's no overlap. Okay, there's no overlap. We know that 22% eat both breakfast and lunch. That won't overlap with the people who skip lunch, because skipping and eating a meal, those two things are mutually exclusive. But maybe skipping breakfast and skipping lunch are not mutually exclusive. Since this is given in percents, we're looking for a final answer that's 100. If it's 100, we know that it's mutually exclusive. But if it's not, then we know that it is not mutually exclusive. That means that there are some overlap. So 62 plus 24 plus 22 is 108. So that means that 8% gets double counted. So no, not mutually exclusive. Okay, so determine the probability that a randomly selected student skips at least one of breakfast or lunch. So let B represent students who skip breakfast, and let L represent students who skip lunch. So that means that the probability of skipping breakfast or lunch is 100%, so that represents 100% of the students, minus 22% who skip neither. 100% minus 22% is 78%. So if we were to draw our Venn diagram, we'll call this one B and call this one L. We know that outside here is 22%, and everything within the two circles is going to be 78%. Question C says, determine the probability that a randomly selected student skips breakfast, but not lunch. So essentially what we're doing is I'm just going to color in here. We're looking for this right here. So if the whole thing, this whole shape here, is 78% of students, the way that we would find out just B, the people who skip breakfast, is we would take the 78% and we would subtract the percentage of students who skip lunch. That is going to leave us with this remaining bit. So we're going to say the probability of B without L, or B not L, so remember this from Unit 3, is the probability of B union L minus the probability of L. So all the people who skip lunch and breakfast, either one of them, or both maybe, minus the probability of people who skip lunch. So this one would be 78% minus 24%, and we're left with 54%. So 54% of the students in the population skip only breakfast.